Think math.
Take a square whose side is 1. Its diagonal has length root 2. By the Pythagorean theorem, 1 squared plus 1 squared is 2, so the diagonal is the square root of 2. But this number starts 1.4142, and its decimals run on forever with no repeating pattern. So can we write root 2 exactly as a fraction of two whole numbers? Let's assume that we can. This is proof by contradiction. Suppose root 2 equals a fraction, p over q, already reduced to lowest terms. Squaring both sides means p squared equals 2 times q squared. Here, p squared is 2 times something, so it is even, but an odd number squared is always odd. 3 squared is 9, 5 squared is 25, so if p squared is even, then p itself must be even. That means p is 2 times some number m. Now substitute p equals 2m. 2m squared is 4mm squared, and that equals 2q squared. Divide both sides by 2, and q squared equals 2m squared. So q squared is even as well, which means q is even too. But wait, if p is even and q is even, both can be divided by 2. The fraction still reduces, yet we said it was already in lowest terms. That is a contradiction. So our very first assumption, that root 2 is a fraction, must be false. When an assumption leads to a contradiction, the assumption is false. So root 2 cannot be written as any fraction. It is irrational. A slice of math every day here at Think Math.